Welcome back to another video, grade 11s. In this video, we're going to finish off question number 6. Question 6.2 says, when sulfuric acid reacts with water, it ionizes in 2 steps. Remember, to ionize means to react with water to form ions. Covalent substances ionize, while ionic substances dissociate, as shown in the 2 balanced equations below. We have equation number 1 and equation number 2. Question 6.2.1 says, define an acid in terms of the Bronsted-Lowry theory. So according to the Bronsted-Lowry theory, we say that an acid is a proton donor or a hydrogen plus ion donor, hydrogen ion donor. And we're going to get 2 marks for this. If you define the acid in terms of the Arrhenius theory, you're not going to get any marks, so please be careful. Question 6.2.2 says, write down the formula of the conjugate base of HSO4-. The conjugate base of an acid is formed when the acid donates a proton. So remember, an acid donates a proton to form the conjugate base and the proton. Okay, so if we're looking for the conjugate base of HSO4-, then we're going to take HSO4- and we're going to take away an H. Don't confuse yourself by looking at the equations. Leave the equations alone and just try to think about what is a conjugate base and how do we form it. We form it by removing a hydrogen from an acid, because an acid is a proton donor. So if we take HSO4- and we take a hydrogen, we are left with SO4 2-. When you take away a positive, it becomes more negative. And for writing this down, you're going to get 1 mark. Now they say write down the formula of the conjugate acid of HSO4-. The conjugate acid of a base forms when the base accepts a proton. So base accepts a proton to form a conjugate acid. So we're going to take HSO4- and we're going to add a proton to it. When you do so, we form sulfuric acid. So the conjugate acid of HSO4- is sulfuric acid. Think about the logic. Don't confuse yourself by looking at the 2 balanced equations. Now they say we must write down the formula of a substance that acts as an ampholyte in these reactions. Now, although it is true that water is a very good example of an ampholyte, if you look at reaction number 1, water accepts a proton in order to form the hydronium ion. If you look at reaction number 2, water again accepts a proton to form the hydronium ion. So in both cases here, water is behaving as a proton acceptor. In other words, water is behaving as a base. But if you look, so therefore water is not the answer here. Water is not acting as the ampholyte in these 2 reactions. But if you look at the top, the sulfuric acid loses a proton to form its conjugate base, HSO4-. And then that conjugate base behaves as an acid and gives its proton to the water. So in this case, it is the hydrogen sulfate ion, HSO4- that acts as the ampholyte, not the water. And grade 11s, this brings us to the end of question number 6 on acids and bases. In the next video, we're going to look at the very last problem in this series of videos, and that is question number 7 on redox reactions.